Alright, welcome back to my video. Now, this video will cover fractions, decimals, and percentage, and a few simple problem sums. Now, how can you use this video? You can use it in several ways. I'll advise that you can use it, let's say, when you forget how to simplify fractions, convert between fractions and decimals and percentages. Just take a quick look at this video, and we can get started. It's okay to forget things, just make sure you put in the effort to revise. Let's get started with this. Now, look at the first row of the questions here. Can these fractions be simplified? Now, if it can be simplified, we will say, well, simplify it. If we can't, we just write no. Now, for example, how do we check? In this particular set of questions, I'm just looking at simplification of fractions by 2, 3, or 5. Okay? For example, how do I know if this fraction can be simplified by 2? I look at the last digit. If the last digit is an even number meaning 2, 4, 6, 8. Now, okay, you can consider 0 as 1, although 0 is not an even number. You see, these numbers at the very last digit, for example, 12, 24, 36, 48, 50. These are all even numbers. Then these numbers can be divided by 2. So for the first question, I can divide the numerator and the denominator by 2. And I'll have 2 divided by 2 is 1, 10 divided by 2 is 5, and this is the simplest form. Okay? Now, next one. Again, look at the last digit. It's a 4, it's a 2, remember? These are even numbers, therefore it can be divided by 2. Now, I know some of you could be very good in maths and you can be asking, Mr. Long, why can't I divide it by 4 straight away? Of course you can. But for the purpose of this exercise, and I'm helping students who have difficulty simplifying fractions in the first place, I'm trying to narrow the ways they can simplify fractions to just using 2, 3, or 5 times table. If you can divide by 4 straight away, of course, fantastic, go ahead. But if you are struggling with this, then of course follow with me. So I divide the numerator by 2, denominator by 2, and I'll have 4 divided by 2 is 2, 12 divided by 2 is 6. Now sometimes you may be wondering, after simplifying it once, does it mean the job is over? We must always check. Again, I look at the last digit, 2 and 6. 2 and 6. Isn't this still even numbers? Therefore, this means this fraction can still be simplified further. So I'll divide the numerator by 2, denominator by 2, and I'll have 1/3. 2 divided by 2 is 1, 6 divided by 2 is 3. And I'll carry on doing this without further commentary. Divide by 2, and I'll have 3/7, and I'll do a quick check. 3 and 7, they are both not in the 2 times, they are both not even numbers, therefore I cannot simplify this by 2. And of course I cannot simplify by 5 because I don't see 0 or 5. Now how do I know where can I simplify a number by 5? If the last digit is either 0 or 5, 0 or 5, for example 10, 25, 30, 45, all these numbers are divisible by 5. And how do I know a number can be divisible by 3? For example, it's a very simple trick. Let's give you 21, for example, 22, 24, 237. Now, which of these numbers can be divisible by 3? Of course, small numbers like this is fine, right? This is divisible by 3. This is not. This is. But how about this? This is as well. How do we tell? I just need to add these 2 digits. 2 plus 1 is 3. 3 is in the 3 times table, so this number is divisible by 3. 2 plus 2 is 4. 4 is not in the 3 times table, so this is not divisible by 3. 2 plus 4 is 6. 6 is in the 3 times table, so this number is divisible by 3. 2 plus 3 is 5. 5 plus 7 is 12. 12 is in the 3 times table, so this number is divisible by 3. Don't have to believe me. You just have to do it to see for yourself. 3 times 7, 21. 3 times 9, 27. There. Divisible. No remainder. So when I look at this fraction, I know for sure this is not divisible by 2. It is not divisible by 5. And it's not divisible by 3. How about this? Okay, even numbers, I divide the numerator and the denominator by 2, and I'll have my 4/13. here. Alright, I divide numerator, denominator by 2. I have my 10 and I have my 19. Now for those who have done this as homework, you can do a quick check using this now. This, let me check. Last digit is a 3, not even number, right? It's not a 2, 4, 6, 6, so cannot be divided by 2. 3 is divided by 3, but 2 plus 0 is 2. 2 is not in the 3 times table. This is not divisible by 5. 20 is divisible by 5, but 3 is not divisible by 5. So this is really a simplest form. So yeah, I cannot simplify further. I'll put out a no. This is not an even number. I cannot divide by 2. This is not a 5. It's not a 0. I cannot divide by 5. This is a 3. I can divide by 3. 3 plus 6 is 9. 9 is divisible by 3. So I can divide the numerator and denominator by 3. And I have 1, 12. Here, alright, I can do in a few ways. I can divide by 6 straight away. But since we're not doing 6, let's try something else. I can divide by 3. Or I can divide by 2. Okay? Because 6 and 2 are both even numbers. And I'll have 3, 6. And here, this number, both numbers are in the 3 times table. I can divide numerator and denominator by 3. And then I'll have half. Next one, this one, 9, is in the 3 times table. 4 plus 5 is 9. 9 is in the 3 times table. Yeah, I can divide by 3. And I'll have 3, 15. Let's check again. 3. 1 plus 5 is 6. 6 is in the 3 times table. I can divide numerator and denominator by 3. I'll have 1/5. 1 plus 2 is 3. Yeah, divisible by 3. 1 plus 2 is 3. 3 plus 3 is 6. Okay, 6 is in the 3 times table, so this will be divisible by 3. So I can divide numerator and denominator by 3. I'll have 4. Here I'll have 41. Now, these are even numbers. No, this is an even number, but this is not. So cannot be divisible. It's not divisible by 2. This is not a 5 or 0. I cannot divide by 5. 4 plus 1 is 5 is not in the 3 times table. So this is the simplest form. 6 and 1. Even number, odd number. I cannot divide by 2. 1 plus 6 is 7. 7 is not in the 3 times table. I cannot divide by 3. This is not a 0, it's not a 5. So this is also not divisible by 5. So this one is a really simplest form. I cannot simplify further. Next one, we have this. Okay, this is even number, odd number, so not divisible by 2. 1 plus 6 is 7. 7 is not in the 3 times table, so not divisible by 3. This is not a 0, this is not a 5. Alright, so this is not divisible by 5. This is already in the simplest form. I cannot simplify it further. Alright, I've done those. Now this, I just do one to show about the 5 part. So this is 5. Yeah, this is 0. So this tells me this is divisible by 5. I will not do the rest. Okay, you try it on your own. Next one, this part. You come up with your own fractions that can be simplified. You will work out the answers too. So based on what we learned just now, we talk about a fraction that can be simplified by dividing by 2. So I must know the last digit must be an even number. Let me put out a 2 for example. Last digit must be an even number. Let me put out an 8. Let me make it look a little bit more challenging. Let's say 12, and let me make this 48. Yeah, I've got a fraction that can be simplified by dividing by 2. And I am supposed to work out the answer. So let's work it out. I divide by 2, I'll have 6. I divide by 2, I'll have 24. I divide by 2, I'll have 3. By 2, I'll have 12. By 2, not by 2 anymore. The first part is simplified by dividing by 2. Now I must divide by 3. So divide by 3, 1 divided by 3 is 4. And that's the answer, 1/4. Do the same for the rest. Okay? Now, if you don't want the fraction to be too big, you can make it a smaller one. For example, divided by 3. Yeah? I'll do one for divided by 3 to show you. 3 means that the numbers above and below, when you add them together separately, they must be in the 3 times table. For example, 21. 2 plus 1 is 3. 3 is in the 3 times table. Below I may have 27. 2 plus 7 is 9. 9 is in the 3 times table. So yeah, this is divisible by 3. I'll have 7, 9. Let me do one for 5. The numerator and denominator, the last digit must be a 0 or 5. Let me put a 0 here, and let me put a 5 here. Let me add a number in front and a number in front. So this I can divide by 5, I'll have 2. I divide by 5, I'll have 5. And this is in the simplest form. Remember, you need to come up with the question and you need to solve it. I'll leave these 3 for you to try. Next, let's go on to this. This is now trying to do expression of fractions in either mixed number, improper fraction, or various ways to do fractions and decimals. For example, the first one, express as a mixed number. How to do this? Well, we've done a lot in class. You can do it this way. Right, 7 times 4 times 3, 21. Alright, so I have my 3, this mixed number, right? So I must have a whole number. This is my 3 whole. Remainder 3. And I was dividing by 7 just now. That's the answer. Now I must do the same question but expressed as improper fraction. Improper is very simple. It's just this, 24 divided by 7. That's it. Let's simplify this fraction. I have my 4/5. I keep the first fraction. I've changed the operation from divide to times. And then I flip this. Now I do my 4 times 4 is 16. Numerator times numerator, 5 times 3 is 15. Now, since the numerator is bigger than the denominator, I cannot leave it like this because this will be an improper fraction. Improper fraction is when the numerator is larger than the denominator. So I go to change this to a mixed number. So this will be the same as 15. 16 is the same as 16, 15 plus 1, right? This is 1 whole, and this is 1/15. And that is the answer for this. Next one, addition of fractions. Now, a very, very common mistake that people make when they're not familiar with fractions is they will just add the numerator and add the denominator. You cannot do this. You must first change the denominator to be the same number. I see 4 and 5. And I know that these are in, there's a common factor, a common multiple here, which is 20. For example, what are the multiples of 5? Multiples of 5 are, for example, 5, 10, 15, 20, 25, so on and so forth, right? Common multiples of 4, 4, 8, 12, 16, 20, so on and so forth. I look for the number that is the smallest number, yet they're the same. So I see 20 is the smallest, same number. So these are the common, this number 20 is a common multiple of 4 and 5. So I change the denominator to 20. How do I get the 20? Well, for 5, I use 5 times 1, 2, 3, 4. So 5 times 4, I get 20. Numerator 4 times 4, I have 16. Here, 4. How did 4 get to 20? 1, 2, 3, 4, 5. 4 times 5, I get 20. 3 times 5, I have 15. Then I use my numerator plus, now I can add numerator plus numerator. And I have 31. Denominator, I don't add. I just keep it as 20. Now this is improper. We cannot leave it like that. We need to change this to a mixed number. This will be 1 whole, 11, 20. Right, how do I do this? So you split this up. So you see 31 is the same as 20 plus 11. Okay, 20 plus 11 is 31. 20 over 20 is 1 whole. 11 over 20 is just 11 over 20. 1 whole, 11, 20. Same thing here, you need to make sure the denominator of both fractions are the same, and both of it will be 20. Since I chose the same fraction for you, it's the same fraction. The only difference is the operation changed from plus to minus, just minus. And now 16 minus 15 is 1. 20, you don't minus 20, just keep it as 20. You don't add nor subtract the denominator. This one you're supposed to change this to 2 decimal places. Very simple, 24 divided by 7. Okay, 7 times 3, 21. Now you have 3. Earlier on when we did this, since we're expressing as a fraction, I don't have to add 0 or decimal. But since I'm supposed to do it as a decimal now, I need to put this. Add a 0, bring a 0 down, and then I look at this. Okay, 7 times 4, 28. 2, put a 0. 7 times 2, I get 14. 6. Now, how many times must I keep doing this? It depends. Say 2 decimal places, right? This is the second decimal place, so I need one last digit. Okay, 7 times 8, 56. Okay, I don't have to do any further. I have my 3 decimal places ready, so I have my 3.428. Now I look at the question. I'm required to round to 2 decimal place. So I look at the third one. Third decimal place is 8. 8 is larger than 5, so I plus 1. So 3.43. That's the answer for this. Now this question here says express the fraction as a mixed number or is fraction or mixed number as a decimal. So for example, this one, decimal, right? Simple. 1 0, I move it up here, so it's 0.3. Find the value of this following. Very simple. Times 100, I move my decimal to the right hand side. 1 2, so it's 1.70. Sorry, wrong. It is 170. 170. Find the value of the following. Very simple. 2/3. This is divided by 1. This one I change. I keep the first fraction. I change the second. I change operation. I flip this. Numerator times numerator. Denominator times denominator. Okay. Now next one. Now this something that we have done similarly to just now. Just now, remember, I repeated a question. Round off to 2 decimal place. So number 26, I repeated here. Okay, lucky you. But this 2 is round off differently to a whole number to 1 decimal place. So I need to see how you express this part. How many decimal places are you actually going to show me in your working? Now, let's take a look at question 33. 33, I repeated. I'm not sure why I'm doing that. I think I copied and pasted too excitedly. So this question is a repeat of this question expressed as a decimal. This question, say, don't have to do because it's repeated. Okay. So if you have done it, leave it. Good. We got extra practice. Okay. Now we change the same fraction as above, but to a percentage. Percentage means that you must always change the denominator to 100 first. So I times 10 times 10. I'll have my 30 over 100. And this, you know, well sure is 30%. Very simple. This already, denominator is already 100. Very simply, 3%. This already 100. Very simply, 24%. Now let's look at question 39. Convert fraction to percentage. Very simple. Change 2 to 100. How to change 2 to 100? Times 50. You get 100. Numerator also must times 50. You have 50. And this will be 50%. How to change 5 to 100? Simple. Times 20. Numerator times 20. Then you will have 3 times 20 is 60. 5 times 20 is 100. You have your 60%. How to change 20 to 100? It's like this. The other way, right? So times 5. Times 5. 45 over 100. And you have your 45%. Right? I won't do this for you. Okay? But I'll just hint to you. This will be your times 4. This will be your times 2. This will be your divide by 2. Okay? Because you need to get to 100. And this is already more than 100. So convert all this fraction to percentage. Well, just practice. Okay? I'm not going to do this for you. You practice on your own. And let's take a look at the last page, which will be the problem sum. A piece of ribbon, 3.8 meter long, was cut into 6 pieces. So ribbon, the whole length was 38 meter. It was cut into 6 pieces. So let's cut. What's the length of each piece? Very simply, 38. Cut means you divide. Okay, you divide into 6. That's all this question is asking you to do. So keep the first fraction, change this to a times, flip this to this. Alright, solve this. 3 times 1 is 3, 8 times 6 is 48. Now let's check, can this be simplified? Is this an even number? No, so not divisible by 2. Is it a 5 or 0? No, cannot be divisible by 5. This is 3, right? Let's try. 4 plus 8 is 12. 12 is in the 3 times table. So this can be divided by 3. And you have your 1, and here you have your 16. And since it's about length, these are all in meters. Don't forget your units. Alright, and that's the answer for 51. This is your exam question. Was your exam question? Not the exact same fraction, but you have done this question in your WA and in your retest 1 and retest 2. So I'm not going to do this for you. I want you to try to do this to show me that you have learned from your mistakes. Movie ticket cost $9. Jane had $110. What is the greatest number of movie tickets that Jane can buy? Well, she has $110. She divide by the cost of one ticket. So I'll do my working here. So if she buy 12 tickets, she will have $2 left. Let's double check. What do I mean? If one ticket costs $9, 12 tickets, right? One ticket costs $9, so 12 tickets will be costing 2 times 9 is 18, 1 times 9 is 9, 9 plus 1 is 10. She'll need to pay $108. Since she has $110, that means that she has $2 left. There's a $2 left here. So what's the greatest number of movie tickets that she can buy? Well, she can buy 12 tickets, then here remaining $2, right? So answer will be just 12. Now this one, she poured 5 liters of juice into some identical bottles. Each bottle contained 8 liters of juice. How many bottles did she have? This question is similar to this. Instead of saying a ribbon was this long, she's saying that she has this amount of juice. Right? Now, so she has a jug that she pours juice into bottles. And each bottle can hold 8 liters. Here there are 5 liters. So how many bottles of juice will she have? Well, I use my 5 liter divided by 8. Okay, so 5, I keep my 5, 1, I change to a times, I flip this to 8 over 5. 5 times 8 is 40, 1 times 5 is 5, 40 divided by 5 is 8. So answer is 8 bottles. Well, I hope this video helps you in getting ready for term 2. And for those who are watching this at any point in time in the year as a revision, all the best in your studies.